12.2 is on circumference of a circle and then lengths of arcs. So for circumference, the formula is equal to 2 pi r, and that's going to be your circumference. C stands for circumference, R stands for radius. So for our first example, calculate the circumference of a circle with a radius of 9. We're just going to plug in our R value, and we're going to give our answer in terms of pi. If you are told to round your answer, you would just type 18 pi into your calculator. And then you can round to 1 decimal point for your final answer. So 56.5 centimeters, and circumference is a distance, or a length, so we're not going to put squared or anything with our answer. Okay. So then for 1b, calculate the radius of a circle that has a circumference of 26. So we know it's 26, and our equation is 2 pi r, and we're looking for our radius. So to do that, we're going to divide both sides by 2 pi. If you're doing this on the graphing calculators and you are not using, or you're dividing by 2 pi, you need parentheses around the denominator. Otherwise, it's not going to give you the correct answer. So if we have 26 divided by 2 pi, that will give us our radius of about 4.138. And that would be our radius. Okay. So relating to that, we are going to be finding arc length. And arc length is going to be a measure or a unit. So it's going to be in inches or just units. It's not going to be in degrees. So when we're finding arc length, we're just finding a fraction of the length around the circle, or a fraction of the circumference. So when we do that, we're going to take the measure, which is always in degrees of an arc, and we're going to divide that by 360. And the reason we're doing that is because it's giving us what fraction of the circle we're working with, and then we're going to multiply that by the circumference, which is 2 pi r. So let's do some examples. So if we find the length, and whenever you're finding the length, you're looking for a measure that's not in degrees. And I think our picture cut off our notes, but we're just finding the length of each arc. So if we look, we're going to find the length of arc AB. So the length of AB is going to be equal to the measure of the arc, which central angles are equal to the measure of the arc, so 60 over 360. And then we're going to multiply that by our circumference, which is 2 pi r of 8. So when we do this, the units of degrees are canceling out with each other. So we're going to have 60 over 360 times 2 pi times 8. And that's going to give us our length of AB. So for now, we're just going to round to multiple decimal points. So we're going to round to 4. And it's a measure of the units, so we're going to label it with centimeters. Okay, so then if we do the next one, it's the same type of thing. The length of EF is going to be 60 over 360 times 2 pi r, and in this case our radius is 11. So then we would just type that whole thing into our calculator, 60 divided by 360 times 2 pi r. And our radius is 11. So this one's going to be about 11.5192, also centimeters. Okay. And our last one, if we're looking for the length of HG, we're going to take the fraction using the central angle, so 120 over 360 times 2 pi, and this one, our radius is 11. So we're going to take 120 divided by 360 and multiply that by 2 pi and 11 for our radius. So that gives us about 23.0383. Also centimeters for this one. So you will need to have this formula memorized. So you do need to memorize 2 pi r for the circumference, and then know that you're putting the fraction of the circle that you are using. Okay. So then if we look at this, they want us to find the circumference of C for the circle. And they are giving us the length of the arc that we are working with. So we know that the length 4.19 is equal to the fraction of the circle we're using, 40 over 360 times 2 pi r. And we know that 2 pi r, that's the circumference. So that's what we're actually solving for. So we don't have to find the radius and then find the circumference. We are just going to figure out what just that part of the equation equals. So if we take 40 divided by 360, that as a fraction is just going to be 1 over 9 if we simplify that. And we're going to be multiplying that by c. And we want to get just c by itself, so we are going to multiply both sides by 9 to get rid of our fraction. And that's going to tell us what our circumference is equal to. 4.19 times 9 is going to be 37.71. And circumference is a measure in inches. And that's our answer. So then for part B, this one wants the measure of arc RS. And when it's asking for the measure, they want the degree measure. So if we set up our equation, we know the length is 44. And we do not know this angle, which is what we need, and it's going to be over 360 degrees because the central angle is going to be equal to the measure of the arc. Then we're going to take that times 2 pi, and then our radius, they told us, was 15.28. We need to get x by itself. So we can start by dividing both sides by 2 pi 15.28. And we're going to put that whole thing in parentheses when we type it into our calculator. So when you type it in, you're going to have 44 divided by, and on the classroom set of calculators, the reason you're putting it in parentheses is so that when it follows PEMDAS, it's not going to divide 44 by 2 and then multiply by everything else. It's going to multiply everything on the denominator first, and then it's going to do the division, which is what we want it to do. Because this is not our final answer, we're going to round to at least 4 decimal points. And this is going to be equal to x over 360. Then to get x by itself, we just have to multiply by 360 on both sides. So I'm going to take my answer times 360, and that gives us about 164.9878 degrees for x. So this one, if we were to round to 1 decimal point, it would just round up to 165 degrees. And that would be our answer. So these ones, you just want to be really careful about identifying the difference between the circumference, the degree measure, and then the arc measure, or the arc length on the circles. Okay. If you want to pause and then try the independent practice on your own so you can see where you're at, you can do that, or you can just follow along. For the first one, we're looking for the length of PQ. So when you are looking for the length, you're just going to take 75 over 360 times 2 pi multiplied by our radius. They give us our diameter, so we have to divide that by 2 to get 4.5. So then PQ, we're just going to type this all into our calculator. 2 pi and then 4.5. Oops. And that gives us our answer of about 5.8905 for our length of PQ. Then we're looking for our circumference. So if we set up our equation again, the length is going to be equal to, so they give us the length, 61.26, equals 270 over 360 times 2 pi r. And remember, 2 pi r is our circumference, so that is what we are looking for. So 61.26 equals, now I'm just going to simplify 270 divided by 360, and that is 3 over 4 as a fraction. And we want to get c by itself, so I'm going to multiply by the reciprocal. And when you multiply by the reciprocal, that's going to get rid of your fraction because the 4's cancel and the 3's cancel, and you're just left with the circumference. So 61.26 times 4/3. That's going to give us our answer of 81.868 for our circumference. Then for our last one, we're looking for the radius. They give us the length of 10.5, and that's equal to the arc measure over 360 times 2 pi r. And we're looking for the radius. So I'm just going to simplify 150 divided by 360. And that as a fraction is 5 over 12. So I'm going to multiply by 12 over 5 to get rid of that fraction. And that gives us 25.2 equals 2 pi r. So I'm going to divide my answer by 2. And then I'm going to divide that answer by pi. And that's going to give us our value for our radius, which is about 4.0107. Okay, if you have any questions on these, just let me know. Make sure you do the homework and then check your